So let's continue our discussion about the atom by trying to understand the Bohr model of the hydrogen atom. So the hydrogen atom is said to have only one proton and only one electron, which is like this. And we know that the electron is revolving around uh, the nucleus where the proton is located, and I can show you that using this animation. All right. So if you guys like contents like this, please click the subscribe button, hit the notification bell to get updated whenever I post videos like this. So guys, if you have any other comments, just leave it there and give us a thumbs up. You can also share this content to your classmates so that they can learn more about science. All right. So we mean to say that the since we knew that the electron is circling around our nucleus, it has its acceleration, and we know that there is also an interaction between the proton and the electron. We know that there is an electric force that is present in between them. So the acceleration is given by the centripetal acceleration is given by the A is equal to V squared all over R. And from Newton's law, we can relate this to the force Fc. And the force that powers the electron is equivalent to the electric force. So later on, we're gonna equate Fe and Fc. So we'll use Newton's law as I mentioned, where F is equivalent to ma. And finally, we'll relate it to F is equivalent to k squared, ke squared all over r squared, wherein this is the electrostatic force. So let's have that equation in the next slide. All right. So as I've said, Fe, or the electrostatic force, must be equal to the centripetal force. So given the two equation, we'll equate them to one another, and we're gonna have k, which is a constant, and later on I'm gonna show you the numbers that play in part of this constant. We have q sub 1 and q sub 2, which is actually the charge of the proton, which is positive E, and the charge of the electron, which is negative E. So technically they are the same, so we can just write this as E to the power of 2, or E squared. And since they have different sign, we write negative there. All right. So later on, the negative sign will play an important role in interpreting the results, all right, of the interaction. So we're gonna have k times q sub 1 times q sub 2 all over r squared, and is equal to Fc, which is equivalent to mass, times the velocity squared all over r. So we can actually remove one r by multiplying r both sides. All right, so we'll see here that r will cancel out, and another r will just remain out there. So from this equation, we can solve for the velocity, all right, of the electron. All right, so once we simplify, it's gonna be like this. So we can solve for the velocity right here, all right, by dividing both sides by m. So let's divide both sides by m. You'll see that it'll cancel out, and v is isolated here, but we're not done yet. So we'll have to take the square root, and I'm gonna show you that in the next slide. So we start from this, and we isolate v and take the square root of both sides. So this is the formula for the velocity of the electron. So we see that the velocity of the electron will greatly change with the radius. So because the mass of the electron is constant, the charges are constant, and 4 pi EO, or the vacuum permittivity, are constant. So the only thing that may vary here is the radius. So the velocity of different electrons are different with respect to their radius. So there's gonna be some discrepancy. All right, so you can use this to calculate the velocity of the hydrogen atom or the electron of the hydrogen atom. So later on, we'll show how this formula works.